there is one more function remaining for today because I want to justify the second DeMorgan law. Right here, the XNOR, which is the exclusive NOR, is made of 4 NOR gates. And by the way, if you just give me 1 second to change the color here, I'm going to justify exactly the formula found in the big summary table in the previous video. And this is going to be the function equals a times b plus a bar times b bar. This is the function representing the exclusive NOR. So now let's find out how this one is going to unfold. We're going to have other 4 gates right here, and we're going to start drawing them. What kind of gates are these? Exactly, NOR gates. We're gonna have NOR gates over here, and another one right here. So from this one, we're gonna find out what's going to happen. Amazingly, the wiring driving this new diagram is exactly the same as for the previous diagram. What's going to be different? The type of the gate. These are NOR gates, these are not NANDs, okay? So right now, we're going to find out what happens here if we realize how these inputs and outputs are combining with each other. If we put letters here, like the input A and the input B, these are becoming the inputs of the first gate. So at the output of it, we're going to have simply A plus B with a bar in the top. But through the wiring, A is propagating right here and B is propagating right here. So whatever these two inputs are, they are going to be combined together exactly as here to get the next result. So it's going to be A plus B with a bar in the top. And simply because of this bubble here, they are going to receive a big bar in the top. In the bottom, you're going to have B plus A plus B with a bar, and everything with a big bar in the top. And guess what? These two are combining with each other to get the result, the output, which is going to be the function is exactly this: A plus B with the bar and with the bar in the top, like that, plus B plus A plus B with the bar in the top, like that. And because of the bubble right here, is going to be a huge bar in the top of the whole thing. Now here is the problem. It's a very complicated expression. So the purpose is what? The purpose is just to break the bar right here in the middle, right here. But when you break it, the mathematical operation is going to switch to what? It's going to switch to multiplication. So let me write over here. I'm going to change the color again. Let me write over here the DeMorgan law we're going to use. The DeMorgan law to use is going to be A plus B with a bar equals, or it's the same as A bar times B bar. So this one is going to be used to simplify the whole thing. So let's start it. So then the function, what function? This one, the complicated over here, we're going to rewrite it like that. A plus B with a bar in the top and with 2 bars. This one is going to be times, and is going to be something similar, B plus A plus B with a bar and with 2 bars in the top. But as you know, and I'm going to write it here again, Boolean rules. A with a double bar is the same as A. It doesn't matter what letter or what expression you use with 2 bars in the top, they cancel each other out, like here. These 2 bars are canceling each other out, and these ones as well. So the function is going to be simplified like that. A plus B with a bar, and all that is going to be times B plus A plus B with a bar. But now we can still simplify because that expression is exactly the DeMorgan law we see over here. So we're going to rewrite it like that. It's going to become A plus A bar times B bar, and all that is times, this one won't change, B plus A bar times B bar. So far so good. So now each term in the equation, like this one, is going to be distributed versus the other ones. And the function becomes A times B plus A times A bar times B bar, and plus second term A bar B bar times B, and A bar B bar, that's interesting, plus A bar B bar times another A bar B bar. And here is another Boolean rule you didn't know before, is that if you take any letter, any expression like H times H, what does it do? If H takes the value 0, then H times H is a 0. If H takes the value 1, H times H is 1. So then, if we do this, we're going to find out that is the same as H. So that's exactly here. Exactly this one times itself is A bar times B bar. But remember what happened before. We have B bar times B. We write it here. B bar times B. This is always a 0. We discussed it before. Why? Because if B bar is 1, B is a 0. If B bar is 0, B is a 1. So one of them is going to be 0 anyway. So 0 times anything else is a 0. So this one cancels out. This one cancels out because you have A times A bar. And then you have the final expression over here. I'm going to write it like the original one, exactly in blue. So then you're going to find out the function actually equals what? A times B, it's exactly this one over here, plus A bar times B bar, and this is exactly the same as the one in the top. So this is how we use the DeMorgan law to simplify. Now, next time, we're going to discuss the functioning of the exclusive OR, exclusive NOR in detail over the workbench. Thank you very much for today. See you next time.